we are going to talk about the SN2 reaction. Before going into SN2 reaction, first we should know the nature of alkyl halide. So alkyl halides are generally represented by Rx. As we know, X are halogens and R is an alkyl group. For example, so now let us take this one, methyl halide, chloromethane. As we know, the chlorine is highly electronegative atom compared to carbon. As a result, what will happen? It will pull the electron towards their side. As a result, it will cause polarization. So, and it leads the halogen becomes partially negative and the carbon becomes partially positive. So now the haloalkane become a highly reactive compound, okay, compared to alkane. Okay, as we know that alkanes are highly inert compound, so it will not undergo any chemical reaction under normal conditions. Okay, so now we understand that haloalkanes are highly reactive compound compared to alkane. So what is called a nucleophile? The nucleophiles are electron-rich species most of the time, and especially it is ready to share its electron. Nucleophiles are has the ability to share its electron, especially towards the either partially positive charge or partially or completely positive charge. Now we'll take this example. Now this OH ion is reacting with the like this, the halide. Now, as we discussed, this carbon is partially positive charge. Now, this lone pair electron has the ability to attack this partially positive charge carbon. As a result, this will displace the halogen, that's chloride ion. Okay, like this. And the chlorine is taking away the both electrons, the carbon bonded electrons along with the chlorine. So chlorine is already having 3 lone pair electrons like this, and this pair also gone like that along with the chlorine. Now it became a negative charge. So this is called as a nucleophilic substitution reaction. This OH is a nucleophile and it has been substituted instead of halogen. So this is called nucleophilic substitution reaction. Now discuss the mechanism of this nucleophilic substitution reaction. As we know, this nucleophile approaches this positive charge carbon. Now what happens? Nucleophile always attack this halogen connected carbon, that positive charge carbon from the back side. So this is the first step. You should know that the nucleophile attack from the the partially positive charge carbon or the halogen connected carbon. Okay. carbon from back side. Okay. Now it forms one or transition state, and there is a big difference between the transition state and the intermediate. The transition state compound, that state cannot be isolated. Okay. So whenever any compound which represented with this square bracket with this symbol, this 2 plus symbol, so this is called as transition state. Okay. If you see in the transition state, you see the halogen and the OH. In the previous case, in the reaction what we learned, the halogen is departed. Okay, now we are studying detailing about the reaction mechanism. You see the OH also bonded to the carbon and the halogen also bonded to the carbon. But you see closely, see the bond. Whatever the bond shown for the OH and the Cl between the carbon is in the dotted line. So that means the bond formation of this OH, that is a nucleophile with the carbon, at the same time the halogen which is connected to the carbon is a departing, both the process happening simultaneously. That means both the bond formation and the bond cleavage is happening simultaneously. That's why we representing this bond as the dotted line. Okay, dotted bond. So this is the representation. Now this is converted to like this. This is the product plus Cl minus. So now what is the second step? The key step, the bond formation and bond cleavage happen simultaneously. Okay, so that means this occurs in the reaction occurs in single step. Okay, now another one more point. Now this is a rate determining step. In the transition state, if you observe closely, there are two reactants are getting involved. That is only this is alkyl halide and this OH nucleophile. That means the rate of reaction is depends on the rate of reaction is depends on both the concentration of two reactants. That is alkyl halide and nucleophile. So that is the nucleophile and alkyl halide. So the rate of reaction depends on both the reactant. That's why this reaction is called as SN2 reaction. So now you can understand it. Rate of reaction is depends on both the nucleophile and alkyl halide. Okay, so this is the summary of SN2 reaction. So these are the key steps. The nucleophile attacks the halogen connected carbon from the backside, and both the bond formation and bond cleavage happen simultaneously. That is single step reaction, and the rate of reaction is depends on both the concentration of alkyl halide and nucleophile. That's why this is called as SN2 reaction. Okay. So in the next lecture, we will discuss about the factors affecting the rate of SN2 reaction. See you.